is Kaiser University as you know it. And this is Kaiser University without any light. Now, why is that? Well, to answer this question, we must look upwards towards the stars. More importantly, we must look towards the giant ball of gas that we call our sun. That all said and done, let's go check it out. Ah, there she is. The sun. Lovely, isn't it? Well, the sun, like everything else in our universe, is made of elements. These elements are obviously on the periodic table. The first major element that makes up the sun is hydrogen, which is found at the very top right here. This one makes up the majority of the sun. The next one being helium. There are a few other elements such as carbon, nitrogen, and oxygen, along with a bunch of other elements that aren't really important. Hydrogen and helium being the two important. Anyway, so what's going on exactly? Well, because of the size and density of the sun, these elements are exposed to an immense amount of stress, causing them to collide forcefully with one another, creating fusion. We can see an example of this right here. This is fusion. And fusion also has a byproduct of light. Isn't that interesting? I think so. Anyway, so now we know that the sun is made of elements, and what exactly is going on that caused the light to be produced. But what exactly is light itself? Well, light itself is a wavelength, and there are many wavelengths in our universe. We can see some right here. Light falls somewhere in the middle and is known as visible light. So, we now have a little base understanding of what light is, and how it's created from the sun. Well, what happens after it's created from the sun? Well, that light goes off forever, and essentially leaves the sun and travels to our home planet, Earth. As we can see, it travels millions upon trillions of miles just to get to our lovely blue marble of a planet. But the journey doesn't stop here. Where you see, the light has to pass through many things before it gets to our planet, such as our atmosphere. And as it travels through the atmosphere, it lands on our planet, which allows us to see. Cool, right? Well, it's not that simple. How exactly does light work, and how does it really allow us to see things? Well, to explain how light works, we can actually tackle this using a common misconception about light. And we can do this by using a simple example with these colored pencils that we can see right here. Now, the object doesn't matter, but what people often think happens is once light enters our world, it comes down and it is actually absorbed into objects. That's not entirely true, because if it was, objects would end up looking like this instead of how they actually look. So, what actually happens? Well, we can see that when light enters our atmosphere, it comes in collision with a bunch of objects, and instead of being absorbed, it is then reflected straight upwards, or actually it's more reflected in every direction. After it's reflected, it retains information. Now, what happens next? Well, it's actually really interesting, for you see, we as people have eyes. This light that's been reflected goes into our eyes, and our brains are able to interpret that light and generate images based off of it. And this is because of how our eyes actually work. If we take a look at this following example, we can see how eyes exactly work. For, you see, eyes are made up of a lot of things. However, the two most important ones are the retinas and the photoreceptors. The retina and the photoreceptor work together to capture the light and then convert it into electrical impulses. They travel along the optic nerve into the brain and are then constructed into images. And that, ladies and gentlemen, is how light is created, what exactly it is, how it travels millions upon millions of light years to reach our planet just so it can allow us to see. We hope you enjoyed this educational video. All that said and done, we will catch you later. Goodbye.